We'd like to, before we start, like to thank uh, lovely professional university and Dr. Amit Srivastava for creating this forum, and so that students and alumni of LPU can understand from so-called industry experts like us on what's happening in this industry and what are the future trends that you can look forward to, and also what does BIM hold in terms of your career aspirations or opportunities. So, before we get into this, let me just introduce myself very briefly. My name is Anirudh Roy, and I am the CEO of TechnoStruct Group of Companies. We are engineering company, electrical and mechanical engineering company based out of San Francisco, California, with offices in San Francisco, Redwood City, Los Angeles, Mexico, and also in India. And we also have a BIM and technology firm in San Francisco and more recently in India as well. And plus, we have a training institute for BIM aspirants. So let's understand what BIM stands for in India. So a lot of people think it's something that's going to happen in the future. Yeah, a lot of people think, maybe it will help, maybe it will not help. I'm not very sure. So it's understood. It's very important that we put things in perspective, in the contextual perspective. So how did this story begin? The story began when the central government, through NIT, wanted to expedite construction. It started with a gentleman from Paris who was doing the Shivaji Stadium redevelopment in Mumbai. He was the CEO, or then CEO, of a company called Arabville, which is a sister concern of Sistra, which designs metros and metro rails, that is. And that project, and he had met us, and he said that when I met the Indian government, they said, how can we finish this project, which was slated to finish in 2 years, in 1 year? Can we use more technology? Can we use more science or more people? Because there are only so many people you cannot finish uh, a single drawing with two people working on it, that kind of thing. So, and he had then professed building information modeling. Uh, and then the government asked Niti Aayog, which is the planning commission, to do its own research on this technology. And Niti Aayog did its own research. BIM was in India. A lot of the uh, private developers like DLF, Unitech, MR, Oberoi Realties, Kalpataru, all of these big developers were using BIM. L&T was using BIM. GMR was using BIM, but government wasn't. So Niti Aayog came up with this finding that BIM as a technology can possibly reduce project cost by 20%. That's a huge number. Huge number. Okay. That's 20 crores in a 100 crore project. And, you know, 2000 crores and 200 crores in a 2000 crore project. It also found out that BIM can also help reduce the construction time of the projects. Now, this is the bigger catch because government projects have the funding. But what government project misses out on is finishing projects on time. So you see, the Calcutta Metro, when it was first built, it took 10 years. The first or second, the Delhi Metro hardly took time to build. And you see all these new lines happening within 1.5 years, 2 years, they're completed. Okay, which is a huge thing. So they want to finish projects faster. Everybody wants to finish project faster because then it saves a lot of time and cost. So Therefore, Niti Aayog then went ahead and urged all the infrastructure ministries to consider the model. And then the government decided that it wants to use the technology for the development of infrastructure projects, such as national highways, which is under NHAI, metro projects, greenfield airports, and railway capacity augmentation projects. There are 920 new redevelopments of railway stations. Okay, but more importantly, it also wants to recommends the use of BIM as a technology in residential developments in order to accomplish the mission of housing for all. That's their mission, one of their programs by year 2022. So you see all these sustainable housing, all these EWS that's coming up. Uh, that's all part of the technology usage and part of this housing for all mission. So what happens is when any for any country, the government pushes a technology, uh, it gets disseminated to all the other players in that industry. For example, when government said it's going to use BIM in metros, think of the number of other consultants who had to adopt the technology. All the design consultants, the general contractors, and all the specialized contractors, the project management companies, the facilities management companies, uh, then the equipment manufacturers had to create their spec sheets in rather than just creating 2D spec sheets. They had to create 3D Revit libraries, family libraries of their product catalog. So all of these people had to start utilizing BIM. So it's a top-down effect, and that is how it spread. That is how it spread in countries like Australia, US, of course, because it was started by US Army Corps of Engineers, and then other countries. But most importantly, widespread in the first world countries is because they have a lack of labor. And when there is a shortage of labor or the cost of labor is very high, then companies or nations have no other option but to invest more and more in technology. So let's understand what BIM is. Because there's a lot of myth. BIM, what is BIM? It's Revit. What is BIM? It's 3D. But let's understand. Let's go a little deeper into understanding what BIM is. Now that we have this forum, but before we go into BIM, we have to understand what are we talking about? What was life without BIM? So this is life before AutoCAD. Now there was life before this as well. The cave dwellers, they had to draw something in order to build it, right? I mean, the people who were doing rebuilding the insides of the caves, when they were building huts, they weren't doing out of their mind. They must have created some kind of drawings, even if it was on sand or papyrus leaves or birch, all of these things that people used to write on or draw on. Okay. And then we invented paper and we started using paper as a medium to draw lines and shapes, so to denote certain elements in construction. Okay, it's still lines. A thick line means structural wall. A slightly narrow line would be an architectural wall. Okay, or you have to write it down. This is a structural wall. It has so many things, and then you have to write down the general notes that this wall has this much thickness. It has this much concrete. What grade of concrete? This much of steel, etc. Internal plaster, external plaster, etc., etc. You have to write these down just by looking. If there is no If there are no letters or dimensions, you will not know what this wall is. And then what happened? Then computers came. And with computers, we had AutoCAD. Okay. Nothing changed. This is very important to know. The guys who were building huts were drawing on sand or some other medium. Then paper came. We were doing the same drawings, similar drawings in paper. And when computers came, we were using computer programs to draw those same lines and shapes. Let's understand. If I take away all these writings, how would anyone know what these stand for? What this wall is, for example. So, and then we realized that we're spending so much time in doing this, and then we're spending again a huge bunch of our time because the guys in construction who are actually doing the construction realize that what you have drawn had so many mistakes because the structural engineer refused to coordinate with the uh, any of the mechanical or electrical engineers or architects for that matter. But then came building information modeling. What changed? You put the information within the elements. So rather than drawing lines and shapes, here you have people who are putting the information there itself. So you all of these things that you see here, this particular column is this column here, and it will have all the information regarding the column. For example, the steel used, again, the concrete, the type of grade of concrete, the fire rating, everything, okay, including scaffolding if required. So that what you see is what you get. If 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 you see a clash here or if you see some confusion in coordination here, it will reflect here. So it's easier to solve it here. So what are we doing? We're creating a digital double. We are constructing a building in a simulated, computerized environment, finding out all the problems associated with it, taking out all, and once you have found the problems and you've solved it, then you take out all the quantities, cost, everything, and then you actually go on site and build it. So it's like uh, genie in a bottle, where he makes the replica of the same building in the next plot. And now, especially now with this COVID situation and people working from home, cloud collaboration is become very important. It was there in all parts of the world where BIM was used, but now even in India, because your consultant who was based out of Singapore, he or she will not come to India right now. So if you have to coordinate with that consultant, you'll have to do it via cloud. Your architects could be in in Ahmedabad. Your structural engineer could be in Punjab. Your general contractor would be at the project site. Maybe your site is in Delhi. Your facade, uh, design architect would be in Singapore. Your mechanical electrical engineering company would be in Bangalore. How do you see all of these models together? You see it via cloud collaboration. So in BIM, we talk about levels or LODs, whichever way. If you're in US, you'll call LOD, you'll talk about LODs, which is level of detail. If you're in UK or in India, you will talk about levels. Level zero, it's nothing, it's just a dot, scratch. It's there is no X and Y coordinate. Level one is partial collaboration. So, for example, you will have your level one, which is your 2D CAD drawing, or your 3D model, which is without intelligence, like a SketchUp model or a Rhino model, and where you can see the shapes, but the shapes have no, We see all of these images everywhere, like when we see about buildings and houses, etc. And level, and in here, we work on, everybody's creating their own different model. For example, we have intelligent models. For example, the architects are creating their own model, the structural guys are creating their own model, the mechanical, the plumbing, the fire, they all create their separate models. And then we create a central model, and then we put them all together, maybe say in um put them all together in, say, Navisworks, like you see here. All the different elements of the model are here: architecture, structure, mechanical, electrical, plumbing. And then you use software like Navisworks to do clash coordination. At the onset, you can use AutoCAD and Revit to see if there are any problems between the drawings and the model. Then you can use Navisworks, AutoCAD, and Revit to link, view, analyze coordination model. And then you can use Navisworks and Revit to understand all the clashes. You see the clashes here. It's very common in a construction site. And then you can resolve clashes and collaborate on cloud, which we are going to come to in a while. And then you have 4D construction simulation, and which is basically a timeliner. So you see how the construction is happening, how it is moving forward. The green ones are the wet areas, and the ones which are completed are the completed ones. So what's happening is we have a BIM model, we have a construction schedule, we have put them together, and we are seeing what the construction is. If I pause it here, so we will see on day something, 19th October 2019, we will see equipment cost is this much, subcontractor cost is this much, the total cost is this. And we can see how it is going, how it should look like on each day. And this is called 4D, or construction sequence. So it's basically a project timeliner. So that, for example, let's understand on this date, if we know, we have anticipated that this building should look like this, these are the areas which should have been completed, these are the areas which are still pending, this, that. However, if we, then this is planned, and if we take this and go to site, and then we realize, oh, the areas that we see here which were supposed to be completed 5 days from now are already completed, which means what? Which means we will soon find material shortage. Or if it is going very late on site, then we will have an issue with warehousing, where we have more materials because than we need, because we are going behind schedule. Now, if you are in a metro city, especially a very congested city like Mumbai, you don't have place for warehousing. So that can be a huge challenge. So let's go back and let's understand the other elements that are there in the level 2 BIM. It's cost and quantity data, which is 5T. Okay. From the models, see, you have created all these elements in the model. And because you have put all the information of the elements here, you can calculate your quantities, which is automated. And based on the quantities, you can derive your cost plan, which means, again, remember the first slide when the government said it could reduce cost? Why? Because it does not use any thumb rules to take out quantities. It is the actual quantities. Because in a BIM environment, you are not really drawing anything, you are constructing. Okay, so that's the difference. What is level 3 BIM? Level 3 BIM is 6D or sustainability, where you can use the model to do a lot of calculation from sunk path analysis to analysis on what the carbon emissions going to be like, and you know basically what's your carbon footprint, and how it's going to fare over a time, over a certain period of time, how the building is going to work or not work, and cloud collaboration. Now, the difference between level 2 BIM and level 3 BIM is in level 3 BIM, we are not creating separate architecture structure M and E model. We are creating a central model, and the architecture also work, and everything is on the cloud. Okay. For example, we can use BIM 360 Glue for BIM 360 Docs, BIM 360 Plan, Field, BIM 360, you know, Coordinate, or and we can use Civil 3D, AutoCAD, Revit, Navisworks, and BIM 360. Okay, for design review, and all of these things happen in a central file. So, and you have people role-based access control. So, a mod guy who is modeling will have editable data, but he or she might not have data on cost. So likewise, so you can separate out everything. It's like if you ever use a file sharing server like FileZilla or something, you will know what I mean. But yeah, this is very important because by the time most of you are students here, so by the time you pass out, and if you get through to one of these larger companies like Atkins, ACOM, WSP, or some of the Indian firms like L&T, GMR, you will have to work on, or Jacobs, or any of these, you'll have to work on collaborative environments. And it's better to understand these now than later. So let's understand. So this is the life cycle of the project, and from software to design simulation to specification, procurement, construction management, facilities management, future flexibility. We talked about, okay, informing best practices, project collaboration. Everything is happening in a cyclic environment and in a single source environment, which is very important to understand in our uh, life. We are seeing everything changing very fast. Okay, we are now talking about implementing AR, VR, and MR, which is artificial reality, virtual reality, and mixed reality in construction space. And we are doing it, maybe not as much in India, but the irony is it's being done by guys like us who are Indians, but we're doing it in other countries because the opportunities in India are growing at a very, very fast pace, a very, very fast pace, but not there yet. So we've come back to what sort of projects are using BIM. So BIM in metro projects in India. It started with it. People think it started with Nagpur Metro, but it actually did not. It started with the Janpat station of the heritage line of Delhi Metro, and I consider myself lucky that I was part of the team. We did a small study for them back in 2014 and or 50, yeah, I think 14, and it can be earlier than that. And we found out that there are 7,000 clashes in in the in the entire design that they had. And however, the government at that point or the metro division were not very keen on adapting. They wanted to do so. They had circulated it internally, the findings and the study, and I still have it. And it took some time for the government to realize the significance of it. But what changed within those time is one, maybe the government changed. If that was a factor, I don't know. I can't comment. Maybe it was that a lot of these construction companies, Indian construction companies, ILFS, GMR, L&T, Shapurji, these people started doing a lot of work in the Middle East, and there they had to use BIM 100%. So they realized the benefits of doing that, and they started using BIM in India. And then the construction management firms in India changed from the local construction firms to large international construction management firms like Leeton, etc. And they brought in BIM. So there were a lot of factors which changed, but then the real big push for BIM in the Indian metro Indian metro construction was Nagpur Metro. And if any one of you here is from Nagpur or go to Nagpur, go to the BIM Museum or the Metro Museum in Nagpur, and you'll see what they have done. They've used 5D BIM technology, and that they've done sort of very good. So what happened is the sequence of events again. Uh, you know, Mr. Ramnath Subramaniam, who is the executive director of Maharashtra Metro, uh, asked that if they can use 5D BIM, and he thought there'd be significant cost saving, and so I mean he thought 5%, which is a huge number in Metro. Okay, and then that flag was taken up by Mr. Brijesh Dixit, who is the MD of Maharashtra Metro, and he spearheaded this. It actually started with Mr. Gadkari, Nitin Gadkari, who's our infrastructure minister, and he wanted to promote BIM and or not BIM but technology, and BIM is one of those pieces in the technology puzzle. And now, nearly all metros are using BIM from Mumbai Metro, which is done by Reliance. There's another line which is done by Tata Projects, Pune Metro, Chennai Metro, Kolkata Metro. And the guys who actually won the deal for the Chennai Metro are REPL, some of you might know, Rudra Abhishek, and they were the L1 for the phase two of the Chennai Metro rail project. Airports. The first airport to use BIM was T3 terminal of Indira Gandhi International Airport, IGI. They It wasn't very successful at the time because BIM was new in India, and India, as Indians, we because we have a huge, even till that point, we had a huge labor surplus. We did not like embracing technology. We don't like new things. Other than new phones. So the first uh, fully utilized first airport where BIM was fully utilized was the Guwahati International Airport. And the Indian Airport Authority of India, AAI, has mandated BIM for any future airports that are coming up. The Jewar Airport, which is coming up in Greater Noida side, that's 100% on BIM. It's been won by a Swiss or a French company, I don't remember, and they have to use BIM. So Bangalore International Airport is leveraged. Terminal 2 has to leverage BIM for sustainability. And residential, which is we think the biggest chunk, is using the biggest amount of BIM. So if you go to any of these big cities, Delhi, Gurgaon, Noida, Faridabad, Ghaziabad, Mumbai, Pune, Nashik, Chennai, Bangalore, even Kolkata, you will rarely find a tier one, the top tier developer who is not using BIM, from MR to DLF. DLF mandates all its project on BIM uh, for a very long time. The younger daughter of in DLF, she is a big advocate of BIM, and she used to come to these meetings as well. And Oberoi Realties in Mumbai, Hiranandani, all of these big developers across India, all of these big general contractors who have worked internationally, like L&T, ILF is gone now, L&T, Shapurji, they're all using BIM. Okay, so the question is not whether BIM is getting utilized in India. It is it getting is it going to be part of the curriculum in engineering? Yes, you know, if not today, tomorrow, definitely. If you go to any reputed construction management master's course, uh, there will be a chapter on BIM, at least one module on BIM. It might not be great, but there will be. Okay. And so, because today, if one wants to be a project manager in 5 years, if you do not know BIM, it's like US. Uh, I have hardly met in the last 5 years that I have, you know, and I've been in, I have multiple businesses there in the construction market. We don't see people in construction sites who do not know BIM. We don't. From a detailer to site superintendent, anyone, everybody knows BIM because that's the norm. It's like saying I don't know AutoCAD. Uh, doesn't work. It's like saying I am a structural engineer and I am not going to learn Stat Pro or ETABS. Doesn't work. Again, the real world, you'll not get a job. And so, if you want to make a mark in the construction field, you have to know BIM, whether it's good for me, whether it's not good for me, whether I'll benefit from it. Those are irrelevant questions because it's a technology which is being pushed by the government and the private sector. So if you want to get a job in the government and private sector, now it's more in the metro cities. It's slowly getting to the tier two cities, and then it's going to have like for example, BMC or Bombay Municipal Corporation has mandated the submission of 3D model for filing building permits from April 2021. Chandigarh municipality is thinking about doing the same. So, and then slowly everybody will follow. So, in conclusion, what I wanted to say is BIM is not the future, it is the present. It is it is like smartphones, whether we like it or not, we have to use it. If we do not know how to use it, then our lives will become very difficult. So, as an engineer or an architect in India or with aspirations of going abroad, these are certain technologies that we need to understand, and it is very important to adopt them as early as possible in your careers than putting it in the back burner. So, without taking too much of your time, I want to say thank you once again to LPU, the Department of Civil Engineering at LPU, and especially Mr. Dr. Amit Srivastava. And thank you so much, and have a lovely weekend ahead. Bye.